Welcome, my neighbors. Today we're going to talk about a different type of tool. Let's get into it. So, what kind of tools are we talking about today? Today we're talking about game making tools, video game making tools. And this one in particular, what I'm talking about is called Godot. It looks like GoDot, but it's not pronounced that way. Anyways, I'm new to this. I wanted to learn about Godot and making a game in, a modern game. And I thought, why not make a video and take you guys through the adventure as well? So let's get back into the tutorial. I'm going to take you through step by step, a little bit each video to run through the main concepts, and then finally running through the entire thing here, and eventually getting to creating your first game. So let's take a look. So let's start with this nodes and scenes. Okay, this is general concept. Nodes are the fundamental building blocks of your game, and they are like the ingredients of a recipe. There are dozens of kinds that can display an image, play a sound, represent a camera, and much more. Okay, so they're defining the key basic fundamental object, which is a node. Okay, nodes have properties, have names, they receive callbacks, uh, which means they can perform functions that are basically what this is saying to me is that they can perform functions that you define based on something that happens in the game or in the game engine. You can extend them with new properties and functions, so you can customize them. You can add them to another node as a child. Okay, so you can compose them. You can combine them together. The last characteristic is important. Together, nodes form a tree, which is a powerful feature to organize projects. Since different nodes have different functions, combine them produce more complex behavior. Okay. As you saw before, you can build a playable character in the camera using character 2D, sprite 2D, camera 2D, and 2D collision shape 2D. Okay. So scenes. When you organize nodes in a tree like a character, we call this construct a scene. Once saved, scenes work like new node types in the editor, where you can add them as a child of an existing node. Well, this actually sounds a whole lot like a node itself, the scene. But I'm guessing there's something more to that. In that case, the instance of a scene appears as a single node with its internals hidden. Okay, it even appears as a node. So scenes and nodes are, let's see what the difference is between them. Scenes allow you to structure a game's code however you want. You can compose nodes to create custom complex node types like game characters that runs and jumps, a life bar, a chest which you can interact with. I'm still guessing a scene is more like a more high level object that you can is used to compose other nodes, but then nodes are also composable. So, hmm. Okay, so they're very much like a node itself. It even says here, I struggle to define what the difference between a scene is. I'm thinking they always have one root node, like the player. You can save them to a local drive and okay, and load them later. You can create them as many instances of the scene as you like. You could have 5 or 10 characters in a game created from a character scene. So I'm taking it says that on top of acting like nodes, scenes have the following. Basically, nodes somehow you cannot save them, the nodes, right? I'm thinking that the nodes, because it's saying those scenes have some additional attributes, like you can save them. I guess nodes you can't save. I kind of not believe that, because if you don't save it, how can you continue your project? You can't just finish your node, right? Okay. I need to think about what they're saying here. They always have one root node, like a player. So I guess nodes don't really always have one single root. Well, that's possible, I suppose, if you have a graph. Um, but it also mentioned it was composed like a tree, right? The nodes. Let's go back here for a minute. Nodes, nodes of blah blah blah, joined together from no, from a tree. Powerful feature in organized projects. Okay, it says it forms a tree, but trees in computer science always have a root. So I don't understand why this is a scene would be different because a scene. Okay, well this is a little bit confusing. You can create as many instances of a scene as you like. Okay, characters in the game. So I guess mm, I'm struggling to try to explain this one or trying to understand it myself. I think a node itself is not something that shows up in your game. It's more, I'm thinking it's more of a definition of a thing or an object, but in order for it to get displayed, I believe it has to be placed into a scene. I think that's one of the things it's not coming. I'm believing that's what this is trying to say. Okay, because otherwise, I don't see a difference between a node and a scene. The only thing is, I feel like the scene is what brings it to the screen. Okay, it was what brings it brings it out into the game. A node is simply just a definition of that object, whereas a scene actually tells it, hey, show up on the screen, okay, and do something. Okay, so creating your first scene. Let's create a first scene with a single node. To do so, create a new project, and after opening a project, you should see an empty editor. So let's go ahead and do that. So let's get into our new project. So let's create a new project here. Um, we'll go walk through. Okay. So now let's see, we get the screen like this, and I think let's go back to the instructions. Let's create a first scene. Okay, we created a new project. In an empty scene, okay, scene doc shows several options to add a root node quickly. 2D scene adds a 2D node. So let's stick with the 2D for now. It's probably easier to understand. We're going to add a single label node to our scene. It's function to draw text on the screen. Okay. Let's do that. So scene, let's go to plus and look at the other nodes. Okay. Other nodes. Let's search for a label. You look at it, everything has a hierarchy, right? Um, so what this means, a label is a control, which is a canvas item, which is ultimately a node. Okay. So let's put that one. Create. So then this, I guess this is your label that shows up. It's very small right now, but let's see what the instructions say. Okay, I think we've gone that far. Label, click the node. Okay, create button. Okay, we've created it. Now, a lot happens when you have first scene and need to change 2B workspace because of the label node type. The label appears selected on the top left corner of the viewport. Okay, like here. And the node appears in the scene dock on the left. Okay. And the node properties appear in the inspector dock on the right. I guess this is the inspector dock, right? Dock. This is inspector. Change the node's properties. Okay. We can edit its text property and let's then change it to the classic hello world. Okay, let's do that. Hello world. Okay. Now I've changed it, but I don't. Oh, it's because it's really small here. Okay, let's take a guess at it. Let's zoom in and see what we can see here. So I think the scrolling has kind of acted a little bit. Oh, okay, there it is. It's here, right on this corner right here. So when we zoom, okay, I think what's this control here? Pan mode. So yeah, so let's just pan it so we can see it. Okay. Now we can. So back to the label. Let's see. Hello world. Now the next step is to run the scene. So to run the scene is Command R or this button right here. Okay, let's try that. This button right here. Let's click that. Well, it tells you to save. So save it into the resources part of the project. Okay, so we'll just leave it label.tscn. Guess that means scene, right? Save. Oh, okay. And here's the I guess the debugger that pops up. So it's running now, and you can see actually very small this hello world over here. So this is your scene. It's actually showing up. So now I guess I was right about one thing is that well, without a scene, there's no game. There's nothing that shows up. You can have many nodes in the system. You can have many nodes that are defined like this. All these different nodes, types, and like labels and if I look at all these things, Node 2D controls, animation players, all these things are available to you. They're like, I guess these are kind of like parts, right? And with you got parts, and without an actual scene, if they don't go into a scene, they don't show up. It's just a library of objects that you can use. So that's really the difference. So what's next? Take a look at the tutorial. Okay, Papa invites you to save the scene. Okay, we've done that. We've done through that. We've gone here. Setting the main scene. To run our test scene, we use run current scene. Okay, that button was actually called run current scene. And the button next to it, run project, allows you to set and run the project's main scene. Okay, so with a lot of scenes, I guess you want to set one as the main. This is the root of your game, right? I think that's what it says. Running the project's main scene is distinct from running current scene. If you encounter this, okay, never mind that. So you're selecting one scene to be the main one. So let's go there. Let's try it. So if I click on this, uh, we can say select. So that label TSCN that we saved earlier becomes here, and that becomes the main scene. But I wonder. So now it is running, but I'm wondering how we can tell from here what your main scene actually is. It doesn't show here actually, and this is not. Hmm. It doesn't make it readily apparent where is your main scene. Except that when you click on this now, it always pops up with the main scene. But how do you know which one's the main? And can you change it afterwards? Well, there must be, but yeah, interesting. I mean, this is just a tutorial. I guess they don't explain that yet, but hmm, maybe the label itself has something in there. Anyways, I get curious about these things, right? When something looks too simple, they're probably hiding a lot of details from you. But anyhow, we will get to it. Let's move on. Okay, next part, we will discuss a key concept of games GoDot, creating instances of a scene. Okay, next. Creating instances. Okay. Godot's approach to instancing described below should not be confused as hardware instance. Okay, never mind that one. Okay, we've seen. Okay, so this one, I kind of read this one before, but basically, what it's saying here is you could take multiple scenes or the same scene and duplicate it across many duplicate across another scene. So, for example, here they have constructed here, pre-constructed here a project for us to import to take a look at. And let's look at it. Let's import it and take a look at how it's arranged inside. So there is a file to download here. Right, this instancing starter.zip. Now I've downloaded this already before, but we can go there now to open it up. So we go to the scene. I'll go through the steps on how to import it. So project, go back to project list. We can go see I've imported it once before, and you know what we can do? We can just delete this so we can um, start from scratch, right? So import, and I just stuck everything everywhere, right? I put it into downloads, and I put it into where we put it from instancing. That's right, instancing. We're going to open that, imports it into our project and directory, neighborhood tools, import. Okay, okay, it's just saying that this was created in a previous version. If you import it, it will convert it to 4.6. That's okay. Okay, so now here's what we have. So we've imported, and now what we see is that we have a main scene here, right? And let's play it, see what happens. Run this project. So if we run the project, what we get is like this. We get we get a red version. I'm not sure why it's red. Okay, but let's see what we want to do with this. But this is the main structure. You have a main scene with all these walls in it, collision 2D shapes. You got wall 2, wall 7, wall 8, 4. I guess these are out of order, which is interesting. I wonder what the order, if has any kind of influence on how these things are drawn into the main scene. Maybe something with how they stack, like the order and in which order they're being processed. I don't know, but mm, it's very interesting when I see these things. I question it because I've done certain things like this before, and I think the order actually matters, but they haven't really explained that yet. So wall container, and then inside that they have several walls, and inside each wall it looks like, well, it looks like this is a node, and then this is a tree of nodes. So a wall has a tree of nodes, which has a child called sprite 2D, which is the sprite meaning the, see there's a texture here, the graphic that actually represented, and then shape 2D, collision shape 2D. I think what they're going to do with this thing is have it possible to interact with, and that's why they have a collision shape. So it means things can bump into it and it can respond to it means it actually has form, and other objects probably cannot overlap them and things like that. That's what I kind of take from here. And you can see multiple instancing of this wall. I think that's what they're trying to describe here. So let's go back to the tutorial and see what they want us to do, what they want us to learn. So here's all the import steps. We'll skip over that, and then we go into here. Uh, says, okay, this is where it really starts. Let's add a ball as a child of the main node. In this scene doc, select the main node. Okay, then click link icon at the top of the scene doc. This button allows you to add an instance of a scene as a child of the currently selected node. Okay, so we go here, click the link. It lets us add something to the scene. Okay, and then which we will select ball, and then a ball will show up here. Okay, now there's a lot of nuances here. I don't know if it goes through this. It goes through this at all, but I think it's important. So by clicking here and linking to the main, what does that achieve but to add it the ball as a child scene of the as the thing. So let's look at this one. Let's take a look at what we learned already. So when it added it, we can see inside the resources folder here, We added a ball.tscn. Now we know that tscn from the last part of things is a scene. So ball is a scene, it's not a node. And in fact, it's true in the documentation. It says, well, you don't save and add nodes to your to your scenes. You add other scenes. So that makes sense. You can load it from the disk, your ball.tsn, and it's here. So let's take a look at the ball itself. So going down here, there's a ball, and this is a scene. And what does it want us to do with this one? You can click on it and drag it towards the center of the view. Okay. Play the game by pressing Command B or F5. Let's just see. And this should fall. Okay, let's do that. It's getting exciting. We can actually play the game. So I think it's just placed here. Command B. Oops. Oh, I forgot to drag the ball. So maybe we click. Okay, so this move symbol, click it here. Maybe let's put it here and click play. Oh, this is cool, huh? That's cool. So basically, by just adding the ball scene into the main scene, it can already interact with all the other objects, all the other scenes which are inside the main scene. Okay, but yet I do want to understand. I do want to understand what's in the order of these things. It seems like it would be important. Let's go back to the tutorial. We'll probably get to that. Now we want to create more instances of the ball. With the ball still selected, press Control D or Command D to call the duplicate command. Okay. Oh, it says let's put a lot of balls on the screen. Okay, let's put a lot of balls on the screen then. Command D becomes a ball two, and I think it's overlapped. Yep. Duplicate, 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 duplicate. Okay, let's play it. Oh, they all fall down as expected. See what else they want us to learn. Okay, you repeat it. Okay. Da, 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 da. So, if I'm not mistaken, I think what they want to teach us is um, the difference between instantiating and. Okay, let's try this. Let's see. Let's go with some. There's more in the future. You can change properties of one ball without affecting the others using the inspector. Okay, they're basically saying that because these are separate instances, you can customize them and not impact the other ones. That makes sense, right? So this is a copy, basically, right? An instance is a copy in this case. It's an instantiation in object-oriented speak, which is a copy. No, it's not a copy. I'm oversimplifying it. It's you're creating an object from something that is, say, in some sense, not alive, like something that's like a template. But once you instantiate it, it becomes an object that's functional. If you can kind of understand what I mean by that. Okay, so this ball. Okay, what does it want to do? Double click on the ball, TSN to open it. In the scene dock on the left, select the ball node. Then in the inspector on the right, click on the physics material property to expand it. Well, wait a minute. It tells us to click on the ball.tsn. So, change the properties of one ball without affecting others using the inspector. Change the default properties of every ball by opening ball.tsn. Make the change to the ball there. Okay. Upon saving, all instances of the ball in the project will see their values update. Okay, so interesting. By importing it into this, into adding it to the project, you're kind of making like a master class of this thing, and then like a master template, which will affect everything. Okay, I think that's it. And then the scene doc inspector and open the physics material property, and then to do what? Change the bounce to 0.5. I think that will change up everything at the same time. So let's go ahead and do that. So ball.tscn, physics material, um, select that. Okay, so bounce. Where's bounce? It says click on this. I'm not sure if I see bounce. Sometimes I think physics material override. Aha. Okay. By clicking this button, you have a bounce, and you can set it. This is set it to 0.5. Okay. Let's set like this way. Save it as it mentions, and then we can run this game again. See what happens. Oh yeah. Now the balls are really bouncy, and all of them are really bouncy. So we're changing the properties of this thing, all of the balls at the same time, right? Now let's try changing individual balls. I think that's what it wants us to do next. So select one of the instance ball nodes in an inspector and set the gravity to 10. Okay. All right. So let's do that. Let's go to the back to the main scene or main TSDN. Let's just select this ball. Or you know what? Let's just duplicate one of these balls, and I'll go put it here. Let's put this one like right here so we know the difference. Or just put it right here and right in the middle. And then we'll change the same property. Bounce with make it 10. Oops, that's 1. Okay, it's 1.0. Save it and let's run. Oh yeah, ball bounced so much it bounced right off the screen here. Let's run that again. I think maybe this. Next frame, no. Okay, to reset it, you probably have to go back. Hmm. Can we shrink? How do we shrink the screen? Shrink it back to the original size. Debug. We'll close it. Okay. So let's put it. Let's put this ball 7 somewhere else, so we can watch it kind of bounce off the screen. Or let's do this. Let's do even better than that. Let's try to move this whole structure over here. Let's see if we can manage that. Wall container. I would think this is wall container. Is it a TSCN? No, that's it's not. So maybe we move the individual walls, or can we stretch them or change its properties? Let's see. I'm kind of thinking that the shape 2D, this itself would need to change, plus the collision shape would need to change with it in order to let's look at this wall. Wall 4. Okay, that's wall 4. So let's make that wall 4 kind of to catch things. Like let's change the angle of it, okay? So let's look at this the sprite. I think you can probably, is this the rotate button? Okay, rotate mode. Okay, we can rotate it like this way. Can we expand it? Scale. Okay. Oh, that's kind of big. Let's move it. Okay, but I'm pretty sure without changing the collision shape, the ball would just fall through. So let's change the collision shape. We'll do the same thing to it. This, and then we'll select it and rotate it. Okay, scale it. It's gonna go bigger, all right? Oops, should match this one. If we can lock these together and do them at the same time, that might be a huge advantage. I see now it's a little bit too big, so let's scale it back a bit. No, no. Okay, okay. Now it's just the same length, and we just gotta move it then. Okay, let's grab our ball back, ball seven. Let's put it here so that now it won't bounce out of this thing. So let's play it. See what happens. Save it. Play it. So stretch to fit. Restart this. No. What's this? Is it no. Override in-game camera? Okay, we're getting a little ahead of ourselves here, but let's see this ball seven. Where does it fall through here or not? Let's see if we fix this. If we've done it correctly. Is there still seven balls? One, two, three, four, four, five, six, seven. There's still seven balls, so this did block it. Okay. Hey, well, it's unintended. I just clicked it and a new ball came down. They must have some custom script. They must have more in this than this game that meets the eye. Okay. Anyways, let's go back to the tutorial. What they want us to do. Okay. So they're just trying to show you the difference between editing the, I guess the main scene versus a copy of it, right? You can edit an instance, or you can edit the main object, the main class itself, right? Now, what I'm curious is it really doing that? Let's do one more experiment before I move forward. If I change it now to prove my thought about this, if that this is the main class, this is the main definition of the object, or the main definition of the scene, then if the ball is the main definition in which all the copies must have, my thought is that if I change it now, even the new balls that I added, if I as long as I didn't override that property, like that physical the bounce factor, as long as I didn't override it, I think they would need to obey my changes here, right? So let's give an experiment, okay? So, well, the best experiment is this. We go back to the main screen, main TSN, right? We change two balls. So this is the ball that bounces a lot. Let's pick another ball here that bounces very little. So let's change this one, ball two, and we'll look at this one and make the bounce nothing, zero. Okay. Okay. So this one goes slow and this one goes fast. So we'll play it. It should be the case. So I think I see that ball. That ball doesn't really want to move. This one. Okay. Kind of hard to tell, right? Which one it is. Okay. You know what? Let's problem solve. Let's delete all these other balls. Ball six. How do we remove it? Is there a delete button? There it is. Okay. So we can delete this ball. Ball six. I don't need any of these balls. In fact, let's just leave two balls. Delete these four ball those are balls. So there's just two. So this ball is going to not bounce very well, and the ball 7 will bounce like crazy. So let's do that. Right. So you can clearly tell which one is bouncy and which one isn't. Very good. Now, let's redefine the ball definition and change all the properties that, weren't overwritten. So, what can we do? Friction. Something that will immediately, very, um, something that will show up very instantly. What about the weight of that ball? Let's make it a very heavy ball, like 10 kilogram ball. Let's see what happens. If I make a 10 kilogram ball, what do you think would happen? Actually, not very different, I would think. The ball's mass shouldn't change the way it falls, but when it hits something, when it collides, it might make a difference, right? Yeah, it's still very bouncy, but so let's take a look. I've changed it to 10 kilograms here. So if I go back to the main scene, let's see how much weight each ball is. Right. See, now it's 10 kilograms, and this one's also 10 kilograms. Physics material. I know I overrided this one. Okay. I know I overrided the bounce on this one. Bounce is 1. Okay. And then for this one, the bounce is 0. Okay. So everything that I changed before is remaining what as the setting that I set it to, right? Zero point 0.5. Okay. 1. This is zero point 0.5. Right. That's right. So everything I changed remains. 5. Just want to double check. Yeah. Okay. All right. Let's make a crazy bounce. Zero point 0.8. And let's run it again. Okay. Very bouncy. Very bouncy. Okay. All right. So we finished experimenting there. So yeah, apparently, as I said, the scenes are the main definition, and instancing is really that is a creation from the definition. So if the definition has something as a property with a certain value, then whenever you create an instance, it will carry the value with it. But if you override it, it will stay the way it is, right? So means it doesn't matter which order you do it in. You can go back and change the ball, and the the properties in the instance will stay the way they are. They're customized, right? So okay, now let's go to the next part. Let's see. Scene instances as a design language. Okay, so they're saying forget everything you know about model view controller and entity relationship diagrams. When you're thinking about, imagining elements that players will see in the game and structure code around them. Like, so you imagine it as in scenes, right? So you got to think like this with this framework. Your stage is your sort of like your main scene. Like, you think of a game, you have a stage, you play on a stage, right? And inside that stage, you will have other scenes, right? You might have enemies like this, player ship, your enemies, obstacles, your HUD. I don't know why the arrow goes this way, but then I'm not sure what the arrows and the directions mean. But what it's trying to say here, weapon, okay, instanced by code, which I think means that you create an instance of a scene, not statically in the designer in the view here, right? Not by declaring it here in your scene, but in response. Okay, so because I don't know what the arrows mean, but I think it's a relationship of which owns which. I think a weapon. This is not the traditional um, kind of or um, instance of relationship that we do in object oriented programming. I think what this one actually means is that the weapon belongs to the stage. When an instance by code, I guess when you create the instance, then you have to tell it where is the parent, which scene actually owns it from that point forward. And I think that's what it means. It means this is an ownership relationship. So things without arrows here, I believe, is saying that they are statically linked to the scene. In other words, they're created during design stage. So for example, this wall contains these walls, this main, they're all linked statically. Okay. So they're created here, which means that's the way your game is designed. Like it's gonna start up like this and it will always be like this unless you change it, right? But from here, I think that what it's saying is here is that once you dynamically create in the code in this response to an stimulus in the game or response to an action, key press or something like that, then there's an ownership. So it looks like a weapon belongs to the player's ship. Well, that makes sense, right? And what I don't understand here is this weapon belongs to this weapon, but the weapon belongs to the stage. An enemy has a missile, right? It creates a missile and has one in there, but it belongs to the stage. And when it belongs to the stage, we know from working on that wall, there's this instancing that once it belongs to a particular scene, it will show up on your screen basically. You can start interacting with it. I think that's what it means. Okay, and then there's a lot of talk here about defining abstract architectures if you're writing your own game engine. I get that. Um, I've written very simple games before, and this is always a thing, right? Figuring out how to design your engine so that you can do a lot of things with it, right? How you could design your engine so that it's generic enough to, for example, um, have a map which has lots of objects in it, right? You end up creating a hierarchy of things, and you need to define that very well. Otherwise you'll be rewriting the game a lot every time you add a feature. So basically, this has to be very well thought out. But here's here's what they've done that thinking for you, and they said if you design like this, where you think about like a main scene, if you think of it in terms of scenes and ownership of other child scenes, then this is how you model your game, right? So, for example, you have a terrain, but everything is owned by that terrain. So, in the terrain, you may have a citadel, you may have a bridge, you may have a player in it, right? And a player, has an HUD. Is it this way? Yeah, the HUD belongs to the player, and the player belongs to the terrain. Okay. You have a citadel, which has a house in it, which has a room in it, and a table and a vase in it, right? That all makes sense. This hierarchy. So basically, at the end, everything is owned by that terrain. So if you're running that terrain scene, it will have all these things in it. So these arrows are ownership. Okay, so yeah, let's just go through those things, right? Um, okay, well, I think we've gone through quite a lot today, and this is very interesting. Whenever we go through uh, these step by step instructions, and it's important to really break it down and try to understand it as we go. If you just read it and go on and go to the next step, there's a lot of times with, in programming, which is really what this is. Don't let it fool you. You still have to know programming and concepts to do this. Um, Computer languages are very precise, and if you don't, you could take something, in my experience, you could take something in one way and just brush over it, and you misunderstand the main concept. And then later, when more advanced you have more advanced usage of those constructs, you won't get it because you've misunderstood the original intent or the original design. So it's very important to try to break it down, try to think about what things mean, and try to validate them as I have done. So in the next video, I'm going to try to get on to the next part of this, which is after nodes and scenes. Is creating. We've done the instances. I think we're going to move on to the scripting languages part of it. So I apologize for making this video so long, but um, the fact of the matter is there is a lot of core concepts that need to be figured out here. Um, I will endeavor to try to make the next videos a little shorter, but I hope you guys enjoyed this video as much as I enjoyed making it, and we'll see you in the next one.